Alright, this video is reintroducing proportional equations. The goal is, or the goals are, that you should be able to relate all parts of an equation, like y equals kx, to the situation it represents, and then two, that you can find the missing information in proportional relationships using the constant proportionality. Alright, so first we have to look at what is a proportional relationship equation. It looks like this. It has this classic setup of y equals kx, and y is going to be the independent variable, x is going to be the dependent variable, and k is going to be the constant proportionality. Alright, and here are some examples of equations of proportional relationships. As you can see, it has that look we were talking about where we have the variable on the left, we have the equal sign, we have a number, and then a variable on the right of that number. And it can look like this, where it has y and x. It can look like this, which is d and t, a and b, w and n, and again, y and x. It doesn't matter. As long as it has that classic setup, it should be considered a proportional relationship. So these variable letters don't matter. And it doesn't matter if it's whole numbers, and it doesn't matter if it's fractions or decimals in terms of that number, k. All right, now we're going to look at 6 equations, and you have to determine whether or not it is a proportional relationship or a non-proportional relationship based on your understanding that it's going to have that classic look of y equals kx. So is this a proportional or non-proportional equation? And the answer, it is non-proportional. It's non-proportional because it doesn't have that look. It has the y, it has the x, but it has this plus, and there's no plus involved in proportional equations. Is this a proportional or non-proportional equation? It's proportional. It's proportional because it has that classic look. It has the y here, the x here, and then the times next to the x. Is this proportional or non-proportional? This is non-proportional. Though it has all the pieces, variable, variable, and a number, you're not multiplying the x by that number, so therefore it is non-proportional. Is this a proportional or non-proportional relationship? The answer is it's proportional. It's proportional because even though it has division involved, and it doesn't look exactly like this, y equals kx, it is actually proportional because we can rewrite it as y equals 1/4 x. And that 1/4 x comes right here from what's called the constant proportionality, the k, which is found by taking the y and dividing by the x. Is this a proportional, non-proportional relationship? Answer, non-proportional. Variable, variable, and a number, but the variable here is an exponent. There's no exponent involved in proportional relationships, so it is non-proportional. Is this a proportional relationship or a non-proportional relationship? This is non-proportional. Has the y, has the x, but since the number is an exponent and proportional relationships don't involve exponents, it is non-proportional. So if we look at these two equations and we try to determine what do you notice about the forms, which equation represents a proportional relationship, it's this one right here, because it has that look, y equals kx. The proportional relationship is of the form y equals kx, while the non-proportional relationship is not. It does have a setup that looks proportional, but then there is this extra, and that extra means that it is non-proportional. All right, so now we're going to look at proportional equations from tables. First, you need to learn how to determine the constant of proportionality in tables by finding the ratio of y to x. Finding the constant of proportionality in a table. If a table represents a proportional relationship between x and y, then the unit rate is the constant of proportionality. The unit rate is whatever y is when x is 1. So if you can look in the table and you see where x is 1, whatever y is, that is going to be your k, or constant proportionality. So let's look at this table here. We have quarters connected to dimes. What is the unit rate of this table? Well, if I go to where quarters are 1, and remember this is the x column and this is the y column, where x is 1, y is 2.5, so the unit rate is 2.5. And what is the equation? Well, it's y equals kx, and we know that the unit rate is k. So therefore, the equation would be y equals 2.5x. So when we talk about proportionality, we're saying that y varies directly as x means that y equals kx, where k is the constant of proportionality. So therefore, we can retranslate this into this. So another way of writing this is that k equals yx, y over x. K, the constant proportionality, can be found by dividing any y by the x that's connected to it. So you don't need to find the unit rate. You just need to be able to find any two numbers that connect in that table, the x and the y. So looking at this table here, we have distance as our x, and we have time as our y. As you can see here, the y is the right column, x is the left column, and k is the constant proportionality. Well, we can't see the constant proportionality here. However, if we take any set of numbers, the x and the y there, the x and the y there, the x and the y there, and the x and the y there, if we divide the y by the x, we should get the same number, and that number will be k, or the constant proportionality. So when we do that, we find that the constant proportionality is 2.5. And then all we have to do is plug in. So y becomes t because we're talking about time. X becomes d because we're talking about distance. And k is that 2.5. And again, that is the same number you found by dividing any of these sets. But it has to be a set. It has to be the y and the x that goes with it, the y and the x that goes with it, the y and the x that goes with it. And you just divide them to get k. So let's look at this equation of proportional relationship. We have a table here that says x and y. When x is 6, 12 is y is 12. When x is 7, y is 14. When x is 8, y is 16. What is the constant of proportionality? Because that's what we have to find first of the table above. Well, we just use this equation right here. K is equal to y over x. And you can pick any 2 points or single points that you want. So I could take 12 and 6. I divide them and I get 2. I could pick 7 and 14. I divide them and I get 2. I could pick 8 and 16. I divide them, y by x, and I get 2. So what's the equation going to be? Well, the equation is y equals kx. Take our 2, put it where x is, and our equation is y equals 2x. Here's another table. We're told that if x is 10, y is 30. If x is 5, y is 15. And if x is 3, y is 9. What's the constant proportionality? Take any set of x and y, divide them, and we find that it is 3. And therefore, the equation would be y equals 3x, where k is 3, and you just substitute in. All right, one more. So we have an equation that, or a table rather, that involves negatives. If x is negative 4, y is negative 1. If x is negative 16, y is negative 4. If x is negative 40, y is negative 10. What's the constant proportionality? Again, take any set of x and y, divide them by y over x, and it doesn't matter what set you pick, you end up with positive 1/4. Put that into our equation of y equals kx, and you can leave it as y is 1/4 x. You could put it as y is 0.25x because that's just equivalent to 1/4. You could even write y equals x over 4 because multiplying by a fourth is the same as dividing by 4. All right, which of the following represent a proportional relationship? The answer is A. Okay, this is the only table that does, because if I take y and divide it by the x that goes with it, you end up with negative 2 every time. These ones, that does not happen every time. You will not get the same unit rate in each of those. So that is the only proportional relationship. What is the constant proportionality for the following table? Well, negative 2. Divide any of these, you get negative 2. Which is the equation that describes the relationship in the following table of values? The answer is y equals 1/2 x. I can see that connection by doing 5 divided by 10, the y divided by the x, and I get 1/2. I would get 1/2 here, 1/2 here, and even 1/2 here. So therefore k is 1/2, and that would be our equation. What is the equation that describes the relationship in the following table of values? Well, if we find first k, we would find k to be 3 over 2, or 1.5. I can get that by taking any of these numbers and doing 6 divided by 4 gives you 3 over 2, or 12 divided by 8 is also 3 over 2. And then just plug it back into our equation, y equals kx. And we end up with c equals 3 over 2p, or c equals 1.5p. What is the equation that describes the relationship in the following table of values? Well, if we find k first, we would find k to be 2.5 or 5 over 2. I can get that by taking any set, such as this. That gives us 5 over 2. Or this set over here, 25 divided by 10, and that gives us 5 over 2. And then we just plug it into our equation, y equals kx, except I just substitute the variables, and I get d equals 5 over 2t, or d equals 2.5t. Now we're going to look at proportional equations from graphs. First, you need to learn how to determine the constant proportionality in graphs by finding the ratio of y to x. So let x and y be two proportional quantities, let k be a constant, and we find that we can take our y equals kx and transform it into y over x equals k. So our constant is going to be y over x again. Okay, so when we talk about the graph, we're talking about this y being the dependent variable, or the y-axis. We talk about this x as the independent variable, or x-axis, and this is the constant proportionality. Now, when looking for the constant proportionality, it might be easier on a graph. If a graph represents a proportional relationship between x and y, then the unit rate is the constant proportionality. The unit rate is whatever y is when x equals 1. So looking at this graph, what's the constant proportionality? Well, I can see it right here. Where x is 1, whatever y is, that is our constant proportionality. So k is 2.5. So what's the equation for this? It's going to be y equals 2.5x. I can go right to that unit rate and just plug in to get the equation. But if we can't find the unit rate, if a graph represents a proportional relationship between x and y, then the unit rates can be found by dividing any y by the x that is connected to it. So looking back at the same graph, let's pretend like we don't have this unit rate here. We can just use another point. So let's use this point. We can find k by dividing the y by the x. And remember, x goes first in our coordinate points, and then y goes second. So that would be 10 divided by 4, which also works out to 2.5. So we end up with the same unit rate, even though we couldn't see the unit rate, let's say it was unclear to us. It doesn't matter what point we pick along this, as long as we can find a clear point and divide them, we'll get the unit rate. So you don't always have to find the unit rate on the graph. You can find it by using any point on the graph. So what would the equation be? Still the same thing. Y equals 2.5x. And I could find that by using the unit rate from here or by finding the unit rate from any point along the line. So let's look at another graph so that I can prove that. I can find the unit rate of this by merely going to where x is 1. And therefore k, the unit rate or the constant proportionality, would be 45 over 1 or 45. Or I could take any point along that line that I can read except for 0, 0, because we know 0, 0 is the only point that won't give us the unit rate. But any other point along the line I can pick, it would give me a set of ratios. Is that each of them is going to end up being 45. That is the k of that line. That is the constant of proportionality that exists for that line. And all of those ratios would still give me 45 if I reduce them down. So we can find the point, we can find the constant proportionality by finding the unit rate or by taking any point and dividing the y by the x. And then recognizing that distance is y, k is the miles per hour, and x is time, we know that k means 45 miles per hour. So the equation would be y equals 45x. And where did that come from? It comes from just our classic y equals kx equation. So let's look at another graph. What is the equation for this graph? Well, this graph doesn't look like the other one we just looked at, or the other two actually. It just has the points, and it doesn't have any line connecting it. But we can still see that it is proportional by looking at the fact that the dots line up in a straight line, and they would eventually pass to the origin. So we can find the constant proportionality. Well, I'm lucky on this one. They give me 1, and I can read it right there. When x is 1, y, I can see it right here, is 8. So k would have to be 8. Now, if I didn't have that point there, I could use this point, which would give me 216. I could use this point, which give me 432, or really any point along that line. I take any point along that line, I divide the y by the x, and you'll get 8. 32 divided by 4 is 8. 16 divided by 2 is 8. So what's the equation? Y equals 8x. What is the equation for this graph? Well, it would be, again, y equals 45x. And I get that by looking either at the unit rate, x is 1, y is 45, that's giving me my unit rate, or I could take any of these other points and divide the y by the x, and that will give me k. What is the equation for this graph? It would be y equals 30x. Again, I can get it by going to 1 and seeing that y is 30. That would be my unit rate. Or taking any of the other points and dividing y by x to get k. What is the equation for this graph? It would be y equals 50x.